Welcome to the Deep Dive. This is the show where we really get into it, break down the complex stuff, and give you the core insights you need to be, well, not just informed, but really understand what's going on.
That's the plan.
Okay, so today, prepare for liftoff. We are heading into the world of space exploration. But maybe not the names you immediately think of, not the giants of old.
No, this is different. We're talking about a company that, believe it or not, started with a guy tinkering in a garage.
Right. And now somehow they're challenging the big players, staking a claim in what's looking like a massive trillion-dollar industry.
It's an incredible story.
Today, we're doing a deep dive into Rocket Lab.
And it really is more than just a company story, isn't it? It's a saga of innovation, maybe sheer grit, too. Our sources, they give us a pretty comprehensive picture. We've got their history, their operations right now, what gives them their competitive edge, which is fascinating, and their roadmap for the future. It's ambitious.
Absolutely. So our mission today is really to peel back all those layers.
Yeah.
We want to show you how this vision that maybe once seemed, I don't know, almost impossible.
Definitely audacious.
Right, audacious. How that's becoming a sort of tangible reality. And crucially, why this isn't just about rockets. It's a story about ingenuity, breaking barriers, and what, democratizing space actually means for innovation, security, and, for you.
So where do we start?
Okay, let's unpack this. When you hear space company, you probably think rockets, right?
Yeah.
Launching stuff.
Pretty much, yeah.
But Rocket Lab is deliberately much more. They call themselves an end-to-end space company. What does that actually mean, end-to-end? It sounds comprehensive.
It is. And what's really interesting, and our sources hammer this home, is that end-to-end means they're not just the taxi to orbit, they're the whole ecosystem.
Okay.
Think of it like, one source used the analogy of the Amazon of space.
Ah, okay. I like that. Explain.
Yeah. Well, imagine Amazon didn't just deliver the package. Imagine they also designed the product, built it, managed the whole supply chain, and provided the software to track it all. That's kind of the scope Rocket Lab is aiming for in space.
Got it. So not just the launch vehicle, the delivery truck. They're also potentially designing and building the cargo, the satellites, managing the logistics, making sure it all works in orbit, handling the data maybe?
Exactly. That whole breadth designing, manufacturing spacecraft components, launching them, managing them on orbit. It creates this really efficient loop. It cuts out a lot of the friction you'd get dealing with multiple companies.
Yeah, I can see how that would save time and probably headaches.
Precisely. And this whole integrated capability, it's built on some key technologies. Our sources break these down pretty well. At the heart of it, obviously, is their Electron rocket.
The workhorse.
The workhorse, yeah. Their small lift beast, as they call it. It's designed specifically to take payloads up to 300 kilograms into low Earth orbit.
And its track record is pretty impressive, isn't it?
It really is. It's a testament to their engineering. As of, mid-August 2025, they'd hit 69 successful launches. And this year, 2025, they've had a perfect streak, 11 for 11.
Wow.
Yeah, like the launch on August 5th for IQPS, that Japanese Earth observation company, just another clean mission. And that consistency, especially for these smaller payloads, it builds huge trust. Failures in this business are catastrophic, right?
Well, absolutely. Millions lost, years of delay.
So for companies launching small sats or, critical defense stuff, that near-perfect record, that's often the deciding factor, reliability over raw size.
Makes sense. But Electron, while it's the current star, isn't their only focus, right? They're looking bigger with Neutron.
Definitely not resting on their laurels, no. Neutron is the future vision. It's a big leap. This is a reusable medium-lift rocket designed to carry much bigger loads up to 13 tons to orbit.
13 tons. That's a significant jump from 300 kilos.
Huge jump. And this is where it gets really interesting because Neutron isn't just about more capacity. It opens doors to totally different missions. Bigger satellites, deploying whole constellations faster, maybe even, interplanetary stuff down the line.
And the timeline. When might we see Neutron fly?
The projected debut is Q4 2025, which, in aerospace terms is practically tomorrow.
Right. It feels soon for something that complex.
Okay.
So, why the big push for Neutron when Electron is doing so well? Is it just scaling up?
It's scaling, yes, but it's also market diversification. Electron absolutely dominates the dedicated small launch market. Neutron lets them grab a big piece of the medium lift market, which is growing fast.
So serving clients with bigger spacecraft or those wanting to launch, say, dozens of satellites at once.
Exactly. It's about offering a full menu covering the whole spectrum of orbital needs.
And it's not just about bigger rockets either. They've adapted Electron for other things, right? Like HASTE.
Right. HASTE, Hypersonic Accelerator Suborbital Test Electron. That's a mouthful.
It is. What's that about? Sounds specialized.
It is highly specialized. It's tailored for hypersonic testing. We saw it used, for example, with the Jake 4 mission on August 10th.
Hypersonic. That's
Yeah.
like Mach 5 plus, right?
Yeah.
Why is testing that so important right now?
Exactly, Mach 5 or more. It's the absolute cutting edge for defense and future aviation. Testing things at those speeds is incredibly difficult and expensive. You used to need massive wind tunnels or risky fleet tests.
Okay.
So HASTE adapts the proven Electron to provide quick, dedicated suborbital flights for this testing. It's basically a customizable, reliable, and importantly, more affordable test platform.
So it speeds up innovation in a really critical area.
Precisely.
Yeah.
And it shows how agile they are, finding and serving these niche high-value markets.
And then there's Photon. We shouldn't forget Photon. These are their own spacecraft.
Yes, absolutely integral. Photon spacecraft are their own custom-built satellite platforms. Designed to be super versatile, they can be configured for Earth observation, communications, even deep space missions.
So this really reinforces that end-to-end idea. They're not just launching other people's satellites. Sometimes they're building the whole thing themselves.
Exactly. Photon is their in-house answer for custom satellite buses. It lets them offer a completely integrated solution from the client's initial idea right through to getting data back from orbit. That flexibility is key Earth observation, communications, deep space science.
And building both the rocket and the spacecraft gives them incredible control over making sure everything works together perfectly.
Unparalleled control. Optimized integration. That's the goal.
Okay, so stepping back, all these pieces, Electron, Neutron, HASTE, Photon, this whole integrated system, what does it mean for the bigger picture? Our sources talk about the democratization of space. That sounds, well, profound.
It really is. Rocket Lab is fundamentally making space more accessible. It's not just for huge government agencies or aerospace giants anymore.
So who are they enabling? All sorts. Innovative startups, maybe tracking climate change, which is obviously critical. Governments around the world, big and small, boosting their national security with satellites.
And why does that broader access matter so much?
Because it fuels global innovation. Lowering the barrier to entry means more ideas get tested, more science gets done, more data gets collected, and for security, it allows for faster deployment, more customization, more resilience. It's about spreading the benefits of space tech, not keeping it locked up.
Moving it from a few gatekeepers to a much wider community. Okay, that makes sense. But how did Rocket Lab even get here? To understand that, we really need to talk about the person driving it all. Peter Beck.
Yes. His story is, well, it's something else. Definitely not your typical Silicon Valley startup narrative.
No kidding. Where did he even come from?
He was born in 1976 in Invercargill, New Zealand, which, as our sources like to point out, is literally the southernmost city on Earth. Remote, more sheep than the people, apparently.
Wow. Okay, so not exactly a space hub. Not at all. But from there, he developed this intense curiosity. Grew up stargazing with his dad, who ran a museum, tinkering constantly, turbocharging old cars, beating water rockets. By his teens, he was apparently the youngest member of the local astronomical society.
A real hands-on kid. And his education path was unusual too, right? No university.
Correct. He deliberately skipped university, went straight into a tool and die apprenticeship at Fisher & Paykel, the appliance company.
Interesting choice. Why?
He wanted to learn by doing. Precision engineering, materials, how things actually get made. And apparently he used the workshop after hours for his own wild experiments, rocket-powered bikes, trying to build jetpacks, that sort of thing.
So the garage tinkerer ethos was there from the start.
Absolutely central to who he is and to Rocket Lab's culture.
And then there was that story about NASA.
Yes. Pivotal moment. Early 20s, working in a government research lab in NZ, doing cool stuff with composites. He decides to visit the U.S., bold as brass, knocks on NASA's door. They turned him away. Lacked the traditional credentials, apparently. No fancy degrees.
Ouch. That could have been the end of the dream right there.
For many, maybe. But for Beck, Just lit a fire under him. He has this great quote about obstacles. When walls are put in front of you, you can choose to turn around or start digging a hole under the wall.
I like that. So the rejection wasn't a stop sign, it was a detour sign.
Exactly. Find another way, push harder, innovate around the problem.
And he did.
Hmm.
Founded Rocket Lab in 2006 with basically nothing.
Just 29 years old, in his garage, zero funding initially, pure bootstrapping. Bought an old cruise missile engine to experiment with, got some crucial early backing from people like Mark Rocket, yes, that's his real name, and where the company name came from.
No way.
Yep. And by 2009, just 3 years later, they launched AT-1, Southern Hemisphere's first private rocket to reach space.
From garage to orbit history in 3 years, that's stunning.
Incredible trajectory, but it wasn't smooth sailing after that, was it?
No, definitely not. Rocket science rarely is. They moved operations to the U.S. in 2013, right? For market access.
Calculated risk, yeah.
Yeah.
Needed access to bigger markets, more investment. But even then, challenges kept coming. The 2017 test failure was a big public setback, could have killed the company.
But they bounced back incredibly quickly. First orbital success in 2018.
Remarkable agility. Shows a culture that learns from failure, doesn't get paralyzed by it.
And Beck is pretty blunt about the difficulties, isn't he? That maze at night with shotguns. Quote.
Yeah, that paints a picture. It perfectly captures the high-stakes, unpredictable nature of the business. One wrong step, boom, he doesn't sugarcoat it.
There's also his philosophy, no money, think. He got that from Rutherford.
Right, Ernest Rutherford. It's all about ingenuity over just throwing cash at problems. Find smarter, more elegant solutions. That thinking is baked into Rocket Lab's engineering. It's how they compete with giants.
So who is Peter Beck today? Still hands-on.
Very much so. Still CEO and CTO. Spends reportedly like 30% of his time actually working with tools in the thick of the engineering.
Wow. Not just a figurehead, though.
Not at all. He's been knighted in New Zealand, featured in documentaries, married with kids, gets up at 4:30 a.m. The dedication is intense.
And the hat-eating story. That was real.
Oh, yeah. Ate his hat on video because he'd previously sworn they'd only ever do small rockets, then pivoted to the larger Neutron. It was a fun way to show commitment, humility, adaptability. Admit he changed his mind when the strategy needed to shift. Says a lot about him.
His ultimate goal is interesting, too. Make space boring and predictable, like mailing a package.
Sounds mundane, but it's actually revolutionary, isn't it? Imagine space access being that routine, that reliable, that cost-effective. A utility, not an adventure every time.
That would change everything. So connecting it all back, Beck's story. It's pure grit, curiosity, defying expectations. Anyone can star reach, basically.
Absolutely. Passion, perseverance, innovation over convention. Rejection isn't failure, it's redirection. Hands-on learning trumps degrees sometimes. Resourcefulness overcomes limits.
It really makes you think, doesn't it? About tackling your own big goals. Maybe you just need to find a way under the wall. Okay, let's shift gears. Let's talk about the fortress Rocket Lab has built, their competitive moat.
Right, because in aerospace, a good product isn't enough. You need sustainable advantages. And Rocket Lab's moat, our sources say, is built on this masterpiece of vertical integration and innovation.
Okay, vertical integration, again, let's break that down. Controlling the whole supply chain, right? Design, manufacturing, launch, operations.
Pretty much everything. And the benefits are huge. First, cost savings. They make critical stuff in-house, avoid supplier markups, control quality directly. Second, speed. That Vic Tasihe mission for the U.S. Space Force.
The 15-month one.
Yeah, contract to orbit in 15 months. That's incredibly fast for this industry. It's only possible because everything's integrated. They can do concurrent engineering, rapid iteration.
That speed must be huge for defense clients needing rapid deployment. And it creates recurring revenue too, right? Not just one-off launches.
Exactly. Satellite components, on-orbit management. It builds long-term relationships, predictable income streams.
So what are the key parts of this full-stack moat?
Well, first, there's spacecraft manufacturing the Photon platform, adaptable for all sorts of missions. Second, component production. Things like solar cells, they power over 1,000 satellites already. Making those critical high-performance parts in-house is a massive asset.
And it's not just hardware, right? Software, too.
Big time. Mission control software, on-orbit operations software. They've logged over 150 orbit years of experience. That's a huge amount of real-world data on reliability and performance. It lets them optimize missions, troubleshoot fast, build client trust.
And the revenue mix reflects this. It's not all launches.
Not at all. Space systems, the satellites, component software, that's now about 70% of their revenue, and it comes with healthy margins, often around 37%, especially from defense contracts and data services. It's a diversified, resilient model.
So how does this integration translate into a real competitive edge?
Well, look at Electron's reliability, over 95% success after the early days. That track record builds immense trust.
And they're pushing reusability with Neutron, sea landings and things.
Yep, that's key for driving down costs and increasing launch frequency. But maybe even more critical is their first mover advantage in responsive launch, the ability to launch super quickly on demand.
That's vital for defense.
Absolutely. And HASTE, for hypersonic testing, is another example of serving those specialized, time-sensitive needs few others can match with such agility.
They've also made some smart acquisitions, haven't they?
Very strategic ones. GEAST, for missile defense sensors. That got them straight into the national security market, where demand is apparently insatiable.
Good timing.
Definitely. And Mynaric for laser communications, that adds another layer, high-speed data transition from space. These aren't random buys, they're targeted moves to deepen the moat.
Okay, inevitably we have to talk about SpaceX.
Hmm.
How does Rocket Lab, this agile speedboat, compete with the ocean liner that is SpaceX?
It's a great analogy and a crucial distinction. You absolutely have to acknowledge SpaceX's dominance in heavy-lift Falcon 9, maybe 170 launches this year alone, Starlink making billions. They're a titan.
Right, unquestionably.
But Rocket Lab isn't trying to be SpaceX. They've very smartly carved out a specific lucrative niche, the small to medium payload market. And that segment, sources say, represents something like 98% of all future satellites.
98%. Wow. So SpaceX builds the giant freighters, Rocket Lab runs the dedicated express delivery vans for most packages.
Exactly. For many customers, especially those with critical or specialized payloads, waiting for a rideshare on a big rocket isn't ideal. You get a shared orbit, a shared timeline, maybe delays.
Right, you lose control.
Precisely. Rocket Lab offers dedicated launches. Your orbit, your schedule, your capacity, that control, reliability, and speed is what wins them business in their segment.
Analysts call these durable moats, right? Sustainable advantages.
They do. And financially, they're backing it up. Solid cash position, about $517 million. A billion-dollar backlog that converts at a healthy 56% rate.
So clients are confident they'll deliver.
Looks that way. Obviously, there are always risks. Competition, execution delays. It's a tough business. But their financials, the defense tailwinds, that vertical integration, it makes them remarkably resilient.
They're building a whole ecosystem, not just rockets. Okay, that makes sense. They're not trying to be mini SpaceX. They're playing a different game. Speaking of which, let's talk about the size of that game, this trillion-dollar sky. How big is the opportunity, really?
Okay, yeah, the numbers here are, well, they're pretty mind-blowing. The overall space economy is projected to hit $1 trillion by 2030.
A trillion, with a T.
Right, and maybe even $1.8 trillion by the mid-2030s. It's not just growth, it's an explosion, a genuine gold rush, but for data, connectivity, orbital access. And Rocket Lab is staking claims in what look like the richest parts.
So how does that trillion-dollar pie break down? Where does Rocket Lab fit?
Well, launch services, the bit most people think of, that's maybe $10 million near term. But crucially, within that, sources say the medium lift segment is desperate for complexity.
Hello, Neutron.
Exactly. Neutron is aimed squarely at that underserved need. It's a major pain point they're targeting.
But launch is just one piece for them, right?
Oh, yeah. Satellites and manufacturing, that's projected at $30 to $50 billion. That's where their Photon spacecraft and in-house component production really come into play. They're building the assets driving this growth.
Okay. And the biggest piece?
The applications. Earth observation, data networks, navigation, science. That's projected at a staggering $320 billion. That's where the value from space is generated. Improving agriculture, monitoring climate, global comms, disaster response, national security.
And Rocket Lab enables that whole downstream chain.
Right. They're not just in launch or manufacturing. They're positioned across the board right in their sweet spot.
Which is small satellites and defense. Why the intense focus there?
Yeah.
Why is demand insatiable?
It's basically supply lagging demand. Think about constellations like Starlink. They need constant, precise deployments of smaller sats. And governments worldwide are rapidly ramping up space-based security. It's a strategic imperative now.
And Peter Beck is pretty confident about this.
Very. He's quoted saying, "One thing I don't worry about is demand." His worry is scaling fast enough to meet it. That tells you a lot about their market assessment.
Why are governments so keen to diversify away from SpaceX, though? Isn't SpaceX reliable?
Oh, absolutely, a critical partner, especially for heavy lift. But national security often demands redundancy. Relying too heavily on one provider creates strategic vulnerabilities.
Single point of failure.
Exactly. So Rocket Lab's responsiveness, their proven track record in the small-medium segment, their growing defense capabilities. It makes them a necessary and attractive alternative for ensuring supply chain resilience.
Got it. So they're not just chasing the market, they're actively shaping it, fulfilling critical underserved needs. Okay, let's look ahead. What's the future outlook? What's on the roadmap?
Well, financially, things look strong. Q2 2025 revenue had a record $144.5 million, up 36% year over year. Q3 guidance is looking even better, sustained growth.
And the stock market has certainly noticed.
Oh, yeah. The stock is up something like 800% in the past year, trading around $43, giving them a market cap near $21 billion. And analysts see more upside, some targeting like 72% higher. That's serious investor confidence.
It's not just hype, though, right? There's a path to actually making
Once they
money.
have a clear path to profitability, yeah. Aiming for mid-2026, significantly, that's timed just after Neutron is expected to debut. Becoming profitable is huge for a company like this, shows they can be self-sustaining.
So what are the big catalysts driving this? Neutron is obviously key.
Monumental. Its debut, targeted late 2025, could unlock maybe $5.6 billion in potential revenue, especially as they achieve reusability. It changes the economics of medium lift.
And they're still pushing Electron hard, too.
Absolutely. Planning over 21 Electron launches for 2025, that's a high cadence. Continuing work for clients like IQPS, deploying constellations like Black Sky, shows the ongoing demand for dedicated small launch.
And they're looking beyond Earth orbit, too. Mars missions, galaxy studies.
Definitely ambitious. They've already delivered the twin spacecraft for NASA's ESCAPADE mission to study Mars's atmosphere, shows their deep space capability. And the Aspera mission for galaxy studies is planned for 2026. It highlights that full-stack approach, building the spacecraft and launching it for cutting-edge science.
Peter Beck's prediction? Bigger than Boeing in 30 years. That's bold.
It's incredibly ambitious, captures the scale of their vision. They want to reshape the entire aerospace landscape.
But not necessarily by going head-to-head with SpaceX on Mars. More complementary roles.
Seems that way. SpaceX focuses on Mars and heavy lift. Rocket Lab consolidates its strength in Earth orbit for small, medium sats, while also enabling deep space science through their integrated approach. It's a different strategy.
And Beck's magic insight ties it together. Combine rocket and spacecraft. That's where the magic happens.
It really does summarize their core advantage. That vertical integration allows optimization, speed, new capabilities that you just don't get with separate providers.
Of course, there are risks. Neutron delays, market shifts.
Always risks in this business. But those strong defense tailwinds and their unique integrated model give them significant resilience. They're built to handle challenges.
Okay, so there you have it. From a garage in New Zealand to aiming for the galaxies. Rocket Lab's journey is, well, it's about innovation, building strong moats, and targeting a massive market. And Peter Beck's story, it's pure inspiration, isn't it? Shows the stars aren't just for the elite.
It really is a compelling story of ingenuity, engineering excellence, and strategic vision changing an industry. And Beck's goal of making space boring like mailing a package, that points to a future where space is far more integrated into our lives than we probably imagine.
So as you think about all this, here's something to chew on. How might Rocket Lab's approach making space cheaper, more routine, more accessible? How might that change things in the next decade? Global access to information, national security for more countries, even our fundamental understanding of the universe.
What happens when you dramatically lower the barrier to orbit for innovators everywhere?
Exactly. What new discoveries, what breakthroughs become possible? It really makes you wonder how our world and our view of everything beyond it could be transformed.
It encourages us to think about the profound implications of space becoming, well, more normal.
Absolutely. We hope you'll share your thoughts, keep exploring. Until next time on The Deep Dive, keep that curiosity burning.